In this lecture, we will see factoring polynomials, section 1.5. So we will start with factoring whole numbers, and then we will do the factoring in polynomials. Now, what does factoring mean? To factor a whole number is whole numbers are 0, 1, 2, 3, and so on. So we generally don't do it for 0. Okay. To factor a whole number is to write it as a product of other whole numbers, which are called factors or divisors. For example, 6 can be factored as 2 times 3. So we say 2 and 3 are factors of 6. Finding the factors of a whole number. Okay, we will do this example. Find all the factors of 48. So the only way to find the factors are to write them as pairs. Right? For example, 1 times 48, 4 times 12, 2 times 24, 3 times 16, 6 times 8. So this gives all the factors. Okay, when we write from the greatest to the least to the greatest, then we have these factors. Now, prime number and composite number. So a prime number is a whole number greater than 1 with only 2 factors, itself and 1. So prime number in Arabic, it's rakam awwali. A composite number is a whole number greater than 1 that is not prime. So when we say composite number, we mean not prime. Now, number 1 is neither prime nor composite. The first 10 prime numbers are these, and the first 10 composite numbers are 4, 6, 8, 9. As you see, they are all even numbers because they are divisible by 2. Prime factorization of a whole number. So a composite number is factored completely if it is represented as a product of its prime factors. Such representation is called the prime factorization of the number. When writing prime factorization of a number, each prime number is found by testing all prime numbers starting from 2. Now let's look at this example. It says write the prime factorization of 120. So one way is to write it as the product of a prime number and another number. So it's 120, you can write it as 2 times 60. So 60, can it be written? It will be 2 times 30. So 30, how about 30? So we can write it as 2 times 15. And 15, okay, we will keep doing it. And we can write 3, 5. And then there's nothing left. These are all prime numbers. So we stop. And we can write the prime factorization of 120 as 2 cubed, so we will write the repeated ones as a power, as an exponent. In the 3 and 5, we don't use powers here because they are only once. They are shown only once. And another quick way to do such thing is to divide. Okay, you start with the number and then you put a prime number here. You divide it. So if it is even, we always start with the smallest one, which is 2. Smallest prime number 2, and then divide by it, so you will get 60. Divide by 2, you will get 13. Divide by 2, so it's divisible by 2, so we divide it by 2. 15 is divisible by 3, not 2, so then we get 5. And after 5, okay, we can divide 5 by 5, and when we reach 1 here, we stop. Then we can collect all of them, all these prime numbers, and write them as a product. So this is the prime factorization of 120. Okay, here please stop the video and try to do it by yourself. Now, I will do the second way. I will start with 72, and 72 is an even number, so I will start with 2. Okay, 2, we divide by 2, you will get 36. Divide by 2, 18. Divide by 2, 9. Okay, 9 cannot be divided by 2, so I will pass and go with 3. Okay, 3, 9 over 3, 3, then 3, and it's 1. So when we get 1, we stop. So these, okay, will give us the prime factorization of 72, which is 2 cubed. Okay, here we have 3 of them, so we write it as 2 cubed, and here 3 squared, so it makes 3 squared. Now, there's one thing important, and we will use it a lot. So this is greatest common factor of numbers. Okay, the greatest common factor or divisor abbreviated as, okay, write it in short, written in short. It says abbreviated means written in short with letters GCF or GCD. Of a list of whole numbers is the largest common factor of these numbers. So for example, the greatest common divisor or factor of 12 and 18 is 6, because this 6 divides 12 and 18. And the common factor of 175 is 25. So because 25 is the biggest number, the greatest number, dividing both, so which means common factor. So how will we find the greatest common factor of a list of numbers? So here is the method. The method is, if you want to find the greatest common of 2 or more numbers, write the prime factorization of each number using exponential notation. For example, we have 60, 48, and we want to find the greatest common factor of them. So we write their prime factorization. Now 60 is this, and okay, I can put here 1 here. If you don't see any power here, it means 1. So then, after listing all the prime factorizations, then choose each common prime factor with the smallest exponent that appears in all factorizations. So what is common here? Look at all of them. So the common thing is here 2, and we will pick 2 here, and we will pick 3, because 3 is common, and 5 not common. Common means mushtarak. So we pick 2, but 2 and 3, and with their smallest power exponent here. 2 is the smallest power here, and 1 is the smallest power of 3. So we write them here. 2 squared times 3 to the 1, 3 to the first, so we get 12. So 12 is the common divisor or factor of these numbers. So if there's no common prime factor, then automatically ground factorization, the greatest common factor is 1. The steps, okay, this is important because we will not only do this greatest common factor for numbers, but also some expressions and some variables in monomials and polynomials. So the steps can be used to find the greatest common factor of monomials. And when finding the greatest common factor of monomials, the variables are treated as prime numbers. Okay, we will see that later. But this is an important remark here. Now, in this example, let's try to find the greatest common factor of 2 monomials. So look at here. One is, we have 2 terms, we have 2 monomials, and we will try to find the greatest common factor. So we write the prime factorization of each. Now here, this part, you don't touch this part, because these variables are treated as prime numbers here, so you do not touch them. Okay, do not touch them. But here, this part here, the whole number, so we can write its prime factorization. You know the procedure, like we do this. Okay, then we can write, and then 63 the same way. Okay, now here, when finding the greatest common factor, we look at the common prime. So look at the common primes here, 3 and 3 here, 7, 7, and x and y, and then we pick the smallest powers of them. Like this one here is the smallest power of 3, and this is the smallest power 1, or you can choose this one, no problem. And then this one is the smallest one, and this one is the smallest one. And then we pick these powers and write the greatest common factor as this. Okay, here, please stop the video and try to do it by yourself, and then I will do it. Okay, I hope you finished it. Now I will try. Now this one is 3 times 5 times a squared d cubed. And this one gives us 2 squared times 7 times a cubed d. And this one gives 2 to the 4th. No, 2 to the 5th, because 2 to the, okay, the 32 is the 5th power of 2. You can do the prime factorization here if you like. So a squared d. Now let's look at here. So no common elements here, no common. When we say common, common in 3 terms. So we have 5 here, but we don't have 5 here. 7, no common in here. No common here, no common, now mushtarak. But here, when we look at here, a, the smallest power a is a squared. So it will be a squared. And the other one will be d, of course, but which power of d? It's 1. So we have the least power as 1. So it will be d to the first power. So GCF will be a squared times d. Now let's look at how to factor in polynomials. Now we're writing, okay, again, as in the whole numbers, writing a polynomial as a product of its factors is called factoring. So for example, 3 times x plus 2y is a factoring of 3x plus 6y. So these 3 and x plus 2y are called the factors of 3x plus 6y. Now, okay, if you did factoring here, and if you're not, if you have some doubts about it, so if you are not sure that this is the correct answer, you can do the multiplication and try to get this one. When you multiply your factors and you get this one, I mean the first polynomial, then it means your factoring is okay. So factoring out the greatest common factor. So in the questions, you will see this term here, like factor out the greatest common factor. So what does this mean? Factoring out the greatest common factor of a polynomial means factor the polynomial using the greatest common factor of monomials used in the polynomial. So let's look at this example here. In this example, we will try to factor out the greatest common factor. So it means you will find the greatest factor here, the greatest factor of them. Then you multiply. Okay, so you will have 2 terms here, and the greatest common factor will be here. So you will take this out. It will be here. So let's try to use our procedure. What's the procedure? Find the greatest common factor of the terms. Look at here, this one, and look at this one. As you see, 3 to the first is the highest power here, and 7, okay, 7 to the first. X squared, we take x because x has the least power. Y squared has the least power. So when you take them and multiply, you will get this one. This is the greatest common factor. After finding this, we will try to find these terms. So when doing them, okay, you can check one by one, like 42, 21. What should I multiply 21 with to get 42? So it's better we put here 2. So 21 times 2, 42. It's done. X squared. So x here there's x, so it has to be there's x. And y cubed. How can I get y cubed? Y squared times y makes y cubed. So what else? We have z here. There's no z here, so we have to put z. So we keep doing the same thing for the other as well. So we get this one. So here, the only thing missing here is 3 here. 3 times, so you can check them by distributing them. Okay, you can do the distribution and check if you can get the same polynomial here. By doing this, you can check, and if you get it, then it means your factoring is correct. Now let's do B. Now first we try to find the prime factorization of each, and then find the greatest common factor of them. Okay, so we skip the writing the factorization process, so we just write the answer here. So greatest common factor of them is 2x times y, and then we will write, okay, this one as 2xy. Okay, we will try to, indeed we are trying to do this, like indeed we are trying to do this. We have 3 terms, we need to put here 3 terms, but you know, one thing is you can do this way, like what times what makes, okay, 2xy times what makes this one. So you can say x squared, and then what times 2xy makes 8x squared y squared. So it will be 4xy. And you can think the same way. What times 2xy makes 6xy cubed. So you can do it one by one, or you can do it like this, you know, whatever you like. And then you can put all the factors, the common factor out. So then we have this one. So this is the factor. So we factored out the greatest factor, 2xy. Now let's look at this example. Please stop the video and try to do it by yourself. Then you can compare your solution with mine. Now we will do factoring out the greatest common factor. Okay. Now it means find the greatest common factor of all, and then write this whole polynomial as a product of greatest common factor and another polynomial. So look at here. I will follow our method. You can do it in short ways, but I will follow the method we taught you. So we break them into pieces, like the prime pieces, prime numbers, 2, 3, x cubed, y cubed. So we will treat the variables as primes. So we check the common prime. So this is the common prime here too. And the common x is common here, so it will be x, and y is common, y. 3 is not common in all of them, so we take only these. So the least power of 2 is 1, least power of x is 1, so the least power of y is 1. So the greatest common factor of these 3 will be equal to 2 times xy. So after finding this, we will try to write it as a product. So it's 2xy times, okay, what is, now we have to put something here. So when deciding this, we look at here, we compare these two. So 2xy, 2 times what makes 4? It's 2. And x times what makes x squared? It's x. Y times what makes y? So it's just 1. So this is 2x times 1. Okay, when you do the same thing, you will get this is 4, this is just 1, and this is y. Then for that one, we have 3, and we will need x squared, and we will need y squared. And when you write it clearly, you will get 2xy times 2x minus 4y plus 3x squared y squared. So this is the answer. Okay, after this, okay, we will start again. Sometimes when we try to do the greatest common factor, so we can end up with having greatest common factor as 1. For example, look at these. So when you try to find a common factor for those, you will get the greatest common factor is 1. So in this case, or there might be some more terms here. In this case, we will try to approach the problem in another way, which is called grouping. So factoring by grouping. Now, sometimes, as I said earlier, the greatest common factor of the monomials can turn out to be just one. So in this case, it is possible to factor the polynomial using the method so-called factoring by grouping. In this method, we break the polynomial into two groups and look for a common factor between the factors of groups. So, of course, if it is possible, sometimes you do this work and you get nothing, it's possible. If it is possible, of course. We will do this method if it is possible to apply. Okay, look at here. This AB plus A and 2B plus 2. So when you look at them, the greatest common factor is definitely 1 because there is no common term in all these four terms. And then we group them. When we group them, we see this group as a factoring like A times B plus 1. And the other group has the factoring 2 times B plus 1. But when you write them as products, you will see there's a common factor between them. So it's B plus 1 seems to be a common factor. So we write it as B plus 1, the common factor here, times A plus 2. So this type of factoring is called factoring by grouping. Now let's look at this example here. So it says factor by grouping. Okay, please try to do it by yourself and then compare the solution with mine. Now, let's start with A. So you will form the groups first. Okay, now in our examples, as you see, it's we take the groups like that, but you might have to switch some terms. You know, if the grouping doesn't work, you might have to switch them. You know, change this one and change this one maybe. If you're lucky, so you don't have to change anything. You don't have to switch them. Yeah, we do the groups and we try to find the greatest common factor for each. So when you look at here, so y is a common term here and x is a common term for these. And do we end up with some common factor here? Yes, 3x minus 2 is a common factor. So you can write it as a common factor here and write the rest here in parentheses. So let's look at B here. So we can make, okay, the greatest common factor for sure is 1 here. So there's no common thing here except 1. So we make the groups and we try to factor them. And after this, we will try to get the common factor. Yes, this is the common factor, x minus 1. And then we write it as a product of x minus 1 times the rest. The rest is x squared plus 1. Now, stop the video here and try to do it by yourself. Okay, and compare your solution with mine. So here okay, we can make the groups like that as ax plus b, x plus a plus b, and it will give you a plus b. This one x times a plus b, and this is a plus b. Now a plus b turns out to be a common factor, so we will take it out. So it will be x here, and what is left here, indeed, this is, if you don't see anything as a product here, it means it's a product with 1. So x plus 1. So this is the factoring of it. Now let's look at here. This is x squared xy plus 2x plus 2y. And this one here, we can write it as x times x plus y. This x is common because, and here it's 2 is common, so you can write 2 times x plus y. And then you can write this one as the common factor x plus y times x plus 2. So this is the factoring of it. Now, factoring by using special factoring formula. So we have some special factoring formulas that we can use. They will make shortcuts for us. So difference of squares is this one here, x squared minus y squared, can be written as x minus 1 times x minus y times x plus y. And these, like x squared plus 2xy plus y squared, we can write it as x plus y squared. And x squared minus 2xy plus y squared can be written as x minus y squared. And the sum of and difference of cubes we have, this x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. And we have this one for the sum. So you might ask this question, where does this come from? Because by the usual methods, it's hard to get this one. Okay, we have shown you, the greatest common factor or the grouping. Now let me show you how we get this factoring with classical methods. Now you can do this way. You can add and subtract x, y. So this is a trick, a mathematical trick here. So for this reason, like this is equal to 0, no one sees this, so it's hard to see this one, to see the factoring here. But if you use this trick, okay, I will show you now in a minute. X squared minus xy, or okay, let's do it like this: x squared plus xy minus y squared minus xy, and then this will give us x times x plus y. And look at this group. Okay, we make this group, and we can write this one as negative y squared plus xy, and this group can be written as negative y times y plus x. So this y plus x and x plus y is the same, so we can write it as x minus y times x plus y. So indeed, these formulas, and also this one and also this one, but here they are coming from the grouping, the factoring by grouping. But here we add a term and subtract it, so we don't see this term here. Okay, we don't see it here, but this is a trick here. So in the same way, we have we can do the same trick and to get this one. So to get this one and this one here, we can use this trick. So it has to be something like this, but I'm not sure. I'm not sure of this. Maybe there will be some more here. I'm not sure. Anyway, you can look it up from internet. Okay. Now we have some remarks on using special factoring formula. So keep them in your mind. It's better you memorize them, especially this is very important. These are also important. Okay, please try to keep them in your mind. So the remarks. Now, when using the special factoring formulas, we should be able to notice. Okay, you have to see. Okay, notice means like kind of see. Okay, be aware of it. If an expression is perfect square or cube. Now, for example, here you can see this one, u to the 6th minus v to the 4th, as a square of something, like u cubed squared, and v to the 4th is v squared. So you can write it as square minus square, like u cubed squared minus v squared. Okay, so this is important. In this case, you might use this one here. Now, one thing is the binomial x squared plus y squared cannot be factored. This is also one important thing. So try not to factor it, because you see here, don't confuse this with this one. So this is negative here. or minus, so we have plus here. If there's plus, this binomial cannot be factored by using the real numbers. So since we are dealing with the real numbers, it won't be factored. Now let's see an example of it. Factor 25a squared minus 64b squared. So the first question is, are these perfect squares? Yes, 25a squared is a perfect square, and 64b squared is the square of 8b. So then when we put them here, we substitute them. Okay, we change it with this one, we change this one with this one. So as we see here, we have square, the difference of squares. So we remember this one here. We remember this formula. Then instead of x and y here, so we have the something squared minus something squared is equal to that. If you say this is x and this is y, so it has to be x plus y, x minus y. So x plus y, x plus x minus y. So we get the factoring now. Now let's look at this factoring here. 16 m to the fourth minus n to the fourth. Again, the first thing you have to think is it squares? Are they squares? Yes, 16 m to the fourth is 4m squared squared. You can verify this, or you can write this one as like 4 times 4 is 16, and m to the fourth can be written as like m squared. So then we can switch it here. Okay, so we can bring 4 to here, so it will be 4m squared. So this is a square of a monomial. And what about n to the fourth? N to the fourth is also the square of n squared. So then now we can change them, these monomials, as perfect squares. And then we have squares here and we have a difference. So we can use the factor formula for the difference of squares. And if we use this one, like this is x and this is y, x squared minus y squared, we get x plus y, x minus y. Okay, so instead of x, we get 4m squared and n squared. And are we done yet? Okay, this is an important question here. So since we have squares here, add plus. We don't remember like squares here and addition. No, this cannot be factored. But anyway, we will go with this one. If this is a square of something, and if this is square, it obviously is, then we can use again this rule again. Okay, the difference between squares. Now let's try to do it here. This is a complete square, and this is a complete square, and we use the formula again, and it turns out to be 2m plus n, 2m minus n, and then we got this factoring for this part. Now we change this one with these two terms, and one thing again, a reminder, this is a complete, the sum of complete squares. So any binomial of the type x squared, y squared, like the square and square, cannot be factored. So then in this case, we will not change this one unchanged, leave it unchanged, but this one as the product of two terms, two binomials. So this is the answer. Now let's do the try and check. And please stop the video and try to do it by yourself, and then compare your solution with mine. Now we will factor the following polynomials. Here we have the first one, 25u squared minus 36v squared. And it's kind of obvious that this is 5u squared, and this is 6v squared, and then we use the factoring for the difference of squares, which says it should be equal to 5u plus 5v, 5u minus 6v. So this is, okay, this is the solution for it. So the factoring of it. Now here we use this one. So you can try to match with x with 5u and 6v with y. Okay, let's try to do the same thing here because we have some difference here. And we know we have two terms and we have difference. So it is possible that we have squares again. Let's try to see the squares. 9 squared, this is m to the 8, so m to the 8 you can write it as 4m to the 4th squared. And here in the same way, this is 4 squared, and we can see this n to the 4th as the square of n squared. So this becomes 9m to the 4th squared and 4n squared squared. Okay, now by using this formula, okay, we can match x with 9m to the 4th and y with 4n squared. We can write the factoring as this. Okay, now this one, we will not try to factor it because we have square here and this is an even power here, so and we have a sum. So it's like the sum of the squares and we have a square here. So we will not try to factor it because it cannot be factored through the polynomials. Now through the real numbers. So let's look at here. If this is a square, if this is a square, so it's 3 squared m squared squared, and this is 2 squared n squared, so it's obviously it's this one is 3m squared squared, and this is 2n squared. So we can use this formula here again. So we'll end up with 3m squared minus 2n times, okay, let's write it this way. And here, this one, we don't change this. So we have the answer, the factoring of b, part b, as this one. So here is the factoring of this polynomial. Now let's look at this example. Factoring perfect squares. So sometimes the given trinomials might be perfect square of binomial. Now in this case, what should we do? Okay, first we check if the polynomials are perfect square. Then if they're perfect square, we factor them by using the square formula. Now let's do so the first thing is you have to look is, do we have perfect squares in this trinomial? Yes, we have. This a squared is one of them, and 64b squared is the other one, because 64 is 8b squared. And then, okay, let's write it again. So we will write this again as the square of a and the square of 8b here instead of 64b squared. So then we will call x a x and 8b y. Then we will check is the middle term equal to 2xy? Now let's check it. 2 times a times 8b is equal to 16ab. So this is, we have 16ab, and this is what we have in the middle term. So in this case, we say yes. If yes, then it means we have this type of sum. It's a trinomial like this, and its factoring is indeed x plus y squared. So we know x is a and y is 8b. Then we will have a squared plus 16ab plus 64b squared is equal to a plus 8b squared. Let's do part B. Now, again, we are looking for the perfect squares in the trinomial, and we see this u to the 10th and 25 are perfect squares. And then we set x equal to u to the 5th, and we will call 5y. Then we check if the middle term, if we have 2xy is equal to 60 u to the 5th. Now we check if x is this and if y is this, so 2xy is 10 times u to the 5th, and which is not equal to 60 u to the 5th. So in this case, we say this is not a perfect square, and we were checking this 2xy because we would use this formula for it. But indeed, we didn't have this one here, so we say it's not a perfect square. So please stop the video and try to do this exercise, and then you can check your solution with mine. Now this one, is it okay? Is it a perfect polynomial? I mean, is it a perfect square? Sorry, 5u squared, and this is 6v squared, and let's check the middle term. This is x. Let's say this is y, and this is 2xy is what? Is it okay? 2 times 5u times 6v. It makes 60uv. Yeah, okay, 60uv. So we got the middle term. So it means this is a perfect square. So it means this is indeed, since we have plus here, it will be 5u plus 6v squared. Okay, let's look at the other one. So when we look at the other one, so we have 11m to the 4th. This is the square of 11m to the 4th, and this is the square of 4 times n squared. So is the middle term, okay, if they are x and y, so this is x and this is y, x and this is y. So let's check if 2xy is, do we have 2xy in the middle? So we say yes, 2 times 11m to the 4th, 4n to the 2nd power. So it gives us the middle term. So yes, it's a perfect square, and this is the square of a difference because we have a minus here. So we see a minus sign here, it's negative. So in this case, we say this is the square of 11m to the 4th minus 4n squared, and it's square. So here, one important thing here is we have to have plus here. I mean, in all, the squares, we have plus here. If there's negative sign or minus, so it's not a perfect square. But is it still factorable? Yes, we can factor it, but not by using the square approach, the square formulas. Now let's look at example 9. We will factor sum and difference of cubes. Now look at these two polynomials. One is involves cubes, but is this a cube of something, and is this a cube of something? Now the first thing is this is a cube, like 2h cubed, and this is a 5k cubed. So we can write it as the cube. The formula, we can use the formula, the factoring formula for the sum of the cubes. Now the formula is this. Now for x and y we use 2h and 5k, and when we substitute them in the formula, so we will get the factoring of it. And in the other exercise we will do the same thing, except the formula. The formula here is with negative here, so it will be, its expansion will be, the factoring here will be this negative plus plus here. So okay, almost same formula, but we will use x cubed minus y cubed formula. Now please stop the video and try to do the try and check by yourself. Okay, this one you can see it says like x cubed plus 3 cubed, and as you see here, this is x cubed minus 3 cubed. You can do the same thing and you can apply the formula here. You will get x minus 3 times x squared minus 3x plus 9. And sorry, this is plus here. So here this will be x plus 3 times x squared minus 3x plus 9. Okay, let's look at factoring quadratic polynomials. Now a quadratic polynomial is a trinomial of second degree. It means it's in this type: ax squared bx plus c. And here a is the leading coefficient, and of course it's not 0. B is the coefficient of the middle term, and c is the constant. Now we will learn how to factor such a polynomial if we have integers here. So if we have integers. So first we list the pairs such that, integer pairs such that their product is equal to c. And then we will choose the pair whose sum is b. Then we can write the factoring as x plus r times x plus s. If there is no such integer pair, okay, let's say integer pair here, integer pair rs with r plus s equal to b and r times s equal to c, then we say it cannot be factored through the integers. Okay, let's look at this example. Now we want to factor each polynomial. Now first we are trying to find the integer pairs whose product is equal to 2. Okay, look at here, this is 2. So we are trying to find the integer pairs whose product is equal to 2. So what are these numbers? So we have two pairs, -2, -1. So you can calculate, so you can check it's plus 2, and plus 2 times plus 1, it makes plus 2 again. So they both satisfy this condition. And the next thing we have to check is their sum. Will it give plus 3? Now choose the pair whose sum is equal to 3. So it's obviously plus 1, plus 2, and plus 1. So it's positive 1 and positive 2. And then you can directly write next to x, each of them next to x, and then it will give you 2 factors. Okay, let's do the other one. So we have a constant term here, -6. So the constant term, we will look for the integer pairs whose product is equal to -6 then. So we have these choices: -2 times 3, it's -6, and 2 times -3, it's -6. So when you look at those, okay, these are all the pairs we can find. These are whose product is equal to -6. And then we have to choose the pair whose sum is plus 1 here. So as you see here, plus 1. So if you don't see any number here, it means like it's plus 1. So the coefficient of x, the middle term, is 1. So 1, which one gives 1? So whose sum is 1? So it's obvious to this one, which if you add it, it will be -1, it will be -5, it will be 5. So it's this one here, it makes 1. So we choose this pair. And after we choose this pair, we put them next to x, and it gives the factoring of the polynomial. Let's factor this polynomial. We cannot use the same method because we have 2 here. The leading coefficient is not 1. So let's try to see what can we do. Okay, the first thing we notice is like if we try to factor this polynomial, we will end up something like this: a polynomial, a binomial times another binomial with degree 1. So there will be x in it, and there will be x in it. So when we multiply them, we will get 2x squared. So the best two choices are 2x and x. Like if you write 2x plus something and then x plus something, then when we multiply them, we will get this 2x squared. So the best two terms here are 2x and x. Now, the next thing we have to do is we have to try the other numbers here. So what can be these numbers? So what are our options? Our options are like when you multiply these two, you'll end up with -6. So in this case, they have to be the factors of -6. So we have several options here. -2 times plus 3, -3 times plus 2, or we might have plus 3 times -2, plus 2 times -3, and plus 6 times -1, and so on. So we will have lots of possibilities. But for each possibility, I mean, we have to test it. So in testing it, we just check the middle term. So this is how we do it. Like if we choose this to be 6 and this to be -1, okay, their product is equal to -6, by the way, here. So this 2x and x, they make 2x squared. So we have to check only the middle term. So multiply it. So you will multiply, and you will after the multiplication, check the middle term of the multiplication. When you use this, I mean, when you try to do this, it will be 2x squared and minus 2x plus 4x minus 6. So we do not check them because they're already the same as this one. So we check only this part to see if this is -x. So obviously this is not. So this factoring, I mean, this choices of the factors is not true. So let's look at the other one. Let's see another choice. 2x, x, yes, plus 3, -2, yes, they make -6. And now let's check the middle term. To check the middle term, okay, you can do this multiplication, but you know the best is, you know, we generally do it this way. We do these two and minus 4x and plus 3x, so it gives you -x. So is -x the middle term here? Yes. So then we say this is the factoring of the polynomial. There are several ways of. Let's do the same question with another way. So maybe you have seen this method before, but since it's more practical than the other one, so I want to show it to you. So if you have this one, this polynomial, so you write here the possible factors of 2x squared. So then you write the possible factors of -6. So we can make, okay, we can make this one as, okay, let's do plus 6 and minus 1. Then after this, we multiply these two and get negative 2x. And these plus 6x. And you have to do always like that. Okay, this is important. Now you add them, they make plus 4x. This plus 4x is equal to the middle term, not same. So you say 4x is not equal to negative x. So in this case, this choice of factors is wrong. So what will we do? So we'll get, let's get back, we will get back to the beginning and we will start over. We will write the new factors. We try other factors, other possibilities. Again, 2xx, these are the best for this, and negative 6. So how about making this one negative 3 and plus 2? We do this, we got plus 4x, we got negative 3x. You add them, you got plus x. Is this equal to this one? No, not same. So this selection is wrong. So again, choose another, but we are close. So in this case, we can, we have 2 or 3 and it will work somehow. Okay, how about making this negative 2 and this one plus 3? Let's check. Let's check. When we add them, it will give you negative x. This negative x and this one. So we got the same thing. So they match. So in this case, we say, okay, that's the correct, this is the correct factors. These are the correct factors. So we write the factorization of it as 2x plus 3 times 2x, I'm sorry, x minus 2. Okay, you will write them here, like this one and this one. It's plus 3, so plus 3, negative 2 and negative 2. And here, you write them this way, like x minus 2 and 2x plus 3. When checking them, you will use cross multiplication. But when writing them as factors, you have to write the same terms on the same row, okay? Now let's try to do this one. Please stop the video and try to do it by yourself. Then compare with my solution. Now let's start with this. I mean, you can, if you can notice first, you have to do it the greatest common factor if possible. So here 2, 8, 6, and they look common. So then you can say this is 2 times x squared minus 4x plus 3. And now we can try to do, okay, 2 is out, so we can try to factor this one, x squared plus 3. So these are, okay, 2 options we have, x and x, and we have some options here, but okay, let's choose plus 1 and plus 3. But this gives you plus 3x, and this gives you plus x. That makes plus 4x, but here is the problem. The problem is we have negative 4x, and here we get plus 4x. Don't match. Okay, they don't match. They're not same. So we change our choices, okay, selections for the factors. But we have some negative here, so for this reason, it's better we deal with some negative numbers here, negative 1, negative 1. So you see here this is negative 3x and this is negative 1x. So when you add them, you get negative 4x, and they match. You see? Okay, they match. So in this case, this will be equal to the factor of this one will be equal to 2 times x minus 3 times x minus 1. If you forget to do this, either you will get 2x minus 6. I mean, this can be here distributed, or this can be distributed here. I mean, if you don't make the factor out greatest common factor, if you don't notice it. Okay, anyway, but since we know it, the greatest common factor exists, so we have to write it at the beginning. This is the factoring of this. Now, let's do this one with the same method here. We have 3x and 2x, one possible solution, and one possible factors here. And negative 2 and plus 1, maybe. Okay, let's check. So this might take some time. Like this, we have many possibilities here. So, but let's check this one. If you're lucky, then with your first choice, you can get to the solution. Are we lucky? Yes, we're lucky. They match. So it means 6x squared minus x minus 2 is equal to 3x minus 2 times 2x plus 1. If they didn't match, we would go on the other possibilities, but this time we were lucky.